Welcome to Inside Astronomy on this beautiful March day where we've had a second week of glorious weather to image with our telescopes. Now I want to discuss today why using a laser collimator might not always be collimating or achieving the results you want, collimating your telescope. So let's go to my observatory and see what the issue might be. As you can see right now, my main imaging scope in the observatory is this beautiful Skywatcher Quattro 10-inch. This was bought second-hand from a gentleman in Belgium, and one of the reasons for this purchase was the mirror had already been checked by the local club in Belgium with a 7-zone mask and was proven to be better than 1/10 wave. So effectively the mirror in here is what we would call a scientific grade mirror, a very unusual mirror to find in a commercial telescope for sure, but nevertheless in this Skywatcher I do benefit from this fantastic mirror. Also, you can see here right now I'm using my TubeTech one-shot color, and this is because we're in galaxy season right now, or the beginning of galaxy season. Certainly Leo is making its presence known in the sky right now, and I want to get plenty of galaxies captured with this camera. Unfortunately what happened was I decollimated my telescope, and I decollimated it with a laser, and I want to show you how that happened and why it could happen to you also. Okay, let's go ahead and remove the camera so I can show you a very important modification that I made to this telescope. And probably 99% of you out there are using a Skywatcher Newton telescope probably have not made this modification and might be struggling a little bit with your collimation because of this. Again, this is not a sponsored video. Nothing here is been paid for a review. Everything here is my own equipment and changes or modifications that I've made to my telescopes myself. These are choices I've made more than 2 years ago now when I first bought this telescope. This is one of the first things that I changed because I realized that centering, having a consistent center for the camera in the telescope was a big issue, and I'll show you why that happens and how that can affect the way you use your laser collimator. So let's go ahead and remove the camera. I'll place it out of the way for safekeeping. So straight away now, with the camera removed, you can see that this is not the normal fixing for Skywatcher telescopes. Normally you have a black ring here with 2 thumb screws, and it's been replaced with this adapter. This is a collet, and basically as you tighten this collet, you have a central collet inside here which closes evenly and circularly around your camera, around the corrector, to ensure that it remains properly centered and fixed within the focuser itself. So this is my laser collimator. It's a far point collimator. The reason I chose this thing is because it has the 2 steps. So if you want 1.25", it's on the first step, and if you want 2-inch, no need to change, you've got it on the second step. The other important thing about this laser collimator, and maybe this is the first thing that we need to ask ourselves, because there are various laser collimators of course out there of different qualities and price grades, let's put it that way. Can you in fact collimate your laser? And more importantly, when did you last check your laser collimator? I know that this laser has been collimated. It has been collimated in the chuck of a lathe and projected to a wall more than 6 meters away, and the spot never moved more than 3 or 4 millimeters. So this is a collimated laser collimator. Now, if I put this in the telescope and I put it in my focus system, in this collet, I can guarantee every time that that will be perfectly centered to the optical axis, due to the fact that I've upgraded the focuser here. The other issue you have with your focuser, and this is one I still have with this telescope, and why I really need to be careful when collimating, and why again you need to understand the purpose of the laser collimator. The only way this can work properly is if your focuser is perfectly orthogonal, i.e. at right angles to the optical axis and perfectly lined up. Otherwise, again, simply using a laser collimator like this will miscollimate your Newton. And in fact, I'll tell you right now, with the fast telescopes that I use, I never put a laser collimator near them. In fact, that is true for the both epsilons that I own, and I'll show you exactly what I use instead. What we're going to do is we're going to turn the laser collimator on now, and hopefully with the dew shield that I have on in my observatory right now, although the light is quite bright, we'll be able to see where the spot is, what position it occupies currently right now on my primary mirror. Now I'll switch for the GoPro footage here. Hopefully you can see from the footage I put together that the laser is not centered on the primary mirror, and that the laser dot is off to my left hand side as I look now at the telescope by about 1/4 to 1/2 inch. Yeah, I know for a fact that this telescope is actually perfectly in collimation right now. So what is the issue? Well, the issue is this focuser. The issue with this is the focuser is not perfectly orthogonal, as I said before, to the optical train. I have introduced some tilt to try to correct it from the plate. However, there's not quite enough correction to make the laser orthogonal to the light path. Therefore, you can see the difference that I'm showing you. But nevertheless, the telescope is perfectly collimated right now. Why have I not replaced this focuser? Well, basically because a friend lent me the Nexus coma corrector stroke reducer. That actually worked in here, except, as you know, when you automate your focusing, you're looking for this lovely hyperbolic curve to have a correct focus, but I only got half because the focuser is too long. It stands too far off the tube right now to allow the Nexus to work correctly. So this focuser in the near future will get replaced with probably a lower profile focuser, something like a Beta steel tracker, something equivalent to that. Once I replace this focuser, what I'll then do is I'll shim the focuser to the tube so that it is perfectly orthogonal to the light path so that a laser will work within this telescope. So okay, we know that this laser is not able to collimate this telescope because we've got issues with the orthogonality, the fact that the focuser itself is not perfectly 90 degrees to the light path. Therefore, if I actually collimated with this, I would be miscollimating the scope. I'd be introducing an error. So how do I collimate this telescope? And to be frank, this tool is the tool that came with my epsilons, with the Takahashi epsilons. And since using it, since having the first epsilon, I've never really collimated with the laser since. And let's go and look at what that tool is and how high-tech it is or isn't. So essentially, here is the Takahashi collimator that I use for all my fast telescopes, and you can see it's nothing more than a Cheshire eyepiece. It has inside a reflective circle and a pinhole and a light path for light to pass through from the side of the tube. Now with the Takahashis, you can also set up this tube with a crosshair to be perfectly aligned within the telescope. Now for the Skywatcher, the only thing I really use is the eyepiece itself. This eyepiece is what I use to collimate my epsilons. Any fast telescope I have, this is the way I go. Once I place this inside the telescope, and if I look through this, if everything I see is concentric and centered, then you know you have a perfectly collimated telescope ready to image the night sky. So the eyepiece itself is just 1.25 inches, nothing special. And you can see it's just a machined peephole effectively with a silver disc at the back that you can use to look into the telescope. Now of course I use the Takahashi holders to place this eyepiece into the telescope, and this now just converts me to 2 inch here so we can place it in the focuser. And of course again we've got to make sure that we're flat, that we're perfectly butt up to that shoulder before we start to tighten down to ensure that we are centered with the tube. So now let's see if we can take a look at the eyepiece and see what we see in the telescope. Of course, This works a lot better with your eye. And yeah, maybe the very, very slight adjustments needed there, but that is a very excellently collimated Newton telescope. In fact, let's just make a slight adjustment. Yeah, that is acceptable. In fact, no, that is great. That is great. Okay, let's show you the issue that 99% of you, I think, will be facing. Well, first of all, here it is. This is the connection ring, the original locking ring from the Quattro. And you can see straight away the way these screws are machined. You know, there's already 1.5 millimeters play just in the screw itself. The screws, again, they're not threaded correctly. There's too much play in that thread, and you know, because you're only pushing on 2 points, that would tend to push something over this way. But the issue is simply this: unless you make a conscious effort, there is so much play in this that you are now able to effectively tip and tilt that laser collimator inside your, effectively your focuser draw tube. In fact, you're going to introduce an error into the collimation of your telescope if you don't make absolutely certain that your collimator is flush up to the tube, to the face, the mating face there, and then slowly and carefully tighten these thumb screws down so as not to introduce any tip or tilt in there. You could be inadvertently decollimating your telescope. That's one of the issues. Again, come back to summarize this. Have a good quality collimator that can be collimated. Make sure you check your collimator and collimate it regularly, especially if you have a mishap or happen to drop this. And when possible, upgrade your focuser locking system. There are a number of manufacturers out there that offer this type of solution to make sure that your collimator, your cameras, wherever it is you place here, is perfectly centered and held securely. I would honestly take this off and throw it in the bin. Okay, to conclude this short video, I would recommend that you get yourselves a nice Cheshire eyepiece. This will, well, serve you well for years and years to come. I did have a Sharp Star copy of the Epsilon, and it also came with a Cheshire eyepiece, but the hole in the center was too big. It was around about 3 millimeters. This one in the Takahashi eyepiece is somewhere around about 1.5 millimeters. It's difficult to measure. Essentially, this encourages you to get your eye very close to this and really centered, and this then improves the accuracy of this solution. So you want a Cheshire eyepiece from not necessarily Takahashi, but a good manufacturer with a small peephole here, somewhere around 1.5 millimeters, would serve you well, and you'll be able to collimate any telescope with this. So finally, thank you for joining me in my observatory for the first time, and I wish you all clear skies. Bye for now.